Have you ever, like, felt the sheer frustration of treating your AI like a really fast but, very literal intern?
Oh, I mean, we have all been there.
Right. Like, you ask it to draft a complex document or, write a sophisticated script, and it spits out the text in seconds. You look at it, and it seems brilliant.
But then reality hits.
Exactly. You realize you are still the one doing the manual labor. You have to copy the code, paste it into your editor, run the tests, watch it inevitably fail, copy the error message, and paste it back into the chat.
Yeah, it's like having an assistant who writes a brilliant report but outright refuses to walk it over to the boss's desk.
Yes. You are left carrying the heavy lifting of the actual execution.
Because you're essentially managing a microtasker. It requires constant, unbroken supervision from you.
Which kind of defeats the purpose, right?
Totally. We rely on these tools to speed up our workflow, but that creates an illusion of massive productivity. When you actually map out the time spent across a full day, the human remains the central bottleneck.
Because the machine is just sitting there waiting on you to ferry information back and forth between different windows.
Exactly. It's completely dependent on you.
Okay, let's unpack this. Because the mission for today's deep dive is exploring what happens when that dynamic completely flips.
And it is flipping rapidly.
It really is. We have a stack of internal documents in front of us, anchored by the 2026 Agentic Coding Trends Report. And the sources detail a fundamental shift happening right now.
A very necessary shift, I would argue.
For sure, we are moving away from passive chat-based AI assistants and transitioning toward, well, active, autonomous team members that execute tasks independently.
To really ground this shift in reality, I mean, we need to look at a highly specific metric from the April 2026 data.
Oh, the financial numbers on this are wild.
They are. A tool called ClaudeCode recently crossed an annualized run rate of over $1 billion.
$1 billion just for an AI coding tool.
Yeah. The financial footprint is massive,
Yeah.
but honestly, the operational footprint is what requires our attention.
Let's talk about that GitHub stat, because that blew my mind.
Right. So as of this report, roughly 4% of all public commits, the actual finalized code changes on the entire GitHub platform, are now attributed directly to ClaudeCode.
4% of the entire public GitHub ecosystem is being committed by an automated system. That's not just a trend. That indicates we are looking at an entirely different class of tool.
Anthropic describes this as an agentic environment.
Which implies the system is no longer just, like, suggesting the next line of text.
Exactly. It is actively working inside a repository, integrating directly with the team's existing tools and processes.
So how does it actually do that? Because that sounds like a massive technical leap.
It is. And the underlying mechanism driving that integration is what we really need to focus on first. Anthropic built ClaudeCode to operate on something called the Agentic loop.
The Agentic loop. Okay.
Yeah, and this is the core architectural difference between ClaudeCode and the Claude you might interact with through a standard web browser.
Right, the browser version everyone is used to.
Exactly. The browser version is heavily optimized to be conversation first. Its primary function is to answer questions, summarize text, or, explain abstract concepts.
It's a chatbot.
Right. But ClaudeCode is built to be action first. It lives directly inside the terminal, the command line interface, where developers actually run their software.
And living in the terminal changes everything about the context the AI has access to, right?
Oh, completely.
Because when you use a browser-based AI, you are forced to constantly explain the context of your project. You have to upload individual files or painstakingly describe your folder structure.
It's exhausting.
It really is.
Yeah.
But because ClaudeCode runs locally in the command line, it uses the project itself as the source of truth. It perceives the environment natively.
Exactly. And that ties back to how the agentic loop functions. It's a continuous cycle: perceive, reason, act, and observe.
Okay, let's walk through how that actually looks in practice for the listener.
Sure. So say a developer asks ClaudeCode to add a dark mode toggle to an application.
It's a pretty standard feature request.
Right. The agent first perceives the environment by reading the local file directory to understand how the project is structured.
It's looking around the room, essentially.
Exactly. Then it reasons about where the visual components are stored and where the global style settings live. Next, it takes action by editing the front-end user interface files and updating the back-end configuration synchronously.
All on its own.
All on its own.
Yeah.
And the crucial part is the observation phase. After it makes those edits, it doesn't just stop and wait for you to check its work.
Which is what the old browser models would do.
Exactly. Instead, it actively runs the local terminal commands to start the application or run the unit tests.
Okay, but what if it breaks something? What if a test fails?
Well, say a test fails because a specific software dependency is missing. Claude reads that error output directly from the terminal, reasons that it needs to install the missing package, runs the installation command, and tries the test again.
Wow.
Yeah, it iterates through this loop autonomously until the objective is complete, or it hits a hard limitation that actually requires human intervention.
We can think about this using a driving analogy. Using a browser-based AI it's similar to having a highly intelligent backseat driver.
That's a great way to put it.
Right, like they hold the map, they understand the traffic laws, and they tell you to take the next left or warn you about a pothole ahead. But you are the one holding the steering wheel.
You're still driving the car.
Exactly. You have to physically apply the brakes and make the turns. The agentic loop is the equivalent of that backseat driver climbing into the driver's seat, taking the wheel, and actively rerouting the car when they encounter a closed road.
Which, in a software project, is a failing test or a broken compilation process.
Exactly. But the leap from providing advice to executing actions is significant. Navigating a massive enterprise software project with millions of lines of code requires immense processing power and memory.
Oh, absolutely.
I mean, an agentic loop is completely useless if the AI loses track of what it was doing 3 steps ago.
Right, if it forgets the map entirely.
Exactly. So the sources point to several major technical power-ups released in 2026 that allowed these agents to actually scale without crashing the systems they operate in.
Yeah, and the most critical infrastructure upgrade was the expansion of the context window. The Opus 4.6 model introduced a 1 million token context window.
1 million tokens.
A million. And to understand why that matters, we have to look at how language models process information. Older models had small memories, meaning they could only look at a few isolated code snippets at a time.
Right, they couldn't see the big picture.
Exactly. They lacked the capacity to understand the butterfly effect of a code base. Like how changing a variable in a database schema might break a user interface component 3 layers away.
So 1 million tokens means the agent can load entire massive repositories into its memory simultaneously.
Yes.
It sees the entire board at once, which allows it to track the long, complicated history of project decisions within a single session without forgetting the original objective.
Spot on. And building on that expanded memory, Anthropic introduced scheduled tasks.
Oh, this is where it gets really interesting.
Right. This feature moves ClaudeCode from being just a tool you run manually on your laptop to a service that runs autonomously on cloud-managed infrastructure.
So it's working while you sleep.
Exactly. Teams can configure the agent to wake up at specific intervals, review incoming code from other developers, investigate automated testing pipelines that failed overnight, or systematically update outdated software dependencies across hundreds of projects.
It's like having an entire night shift of developers.
It really is. And the reports also highlight a structural change in how the AI operates, specifically the implementation of agent teams.
Agent teams, so multiple bots talking to each other.
Basically, yeah.
Yeah.
Instead of relying on a single agent to process a massive task sequentially, a lead agent acts as a project manager.
Okay.
If a team needs to execute a complex database migration, the lead agent maps out the architecture. It then delegates tasks. One subagent writes the database scripts, another updates the back-end application programming interfaces, and a third writes the testing protocols. Yeah, the lead agent monitors their progress in parallel, aggregates their outputs, and ensures everything aligns before finalizing the work.
I can see how that parallel processing drastically reduces the time required for large-scale engineering tasks. But, well, the 2026 rollout included an even more expansive capability called computer use.
Yes, computer use. This is wild.
It is, because this feature breaks the agent out of the text-based terminal entirely. The agent is granted the ability to read the pixels on a screen, calculate coordinate maps, and actively control the mouse and keyboard to interact with graphical user interfaces.
It is literal screen control.
Right. So it can open a web browser, navigate to a staging environment, and click through the application exactly like a human quality assurance tester.
Yeah, it can verify that a button actually changes color when clicked, or that a form submits correctly when filled out.
Okay, but we have to analyze the risk surface here. Wait, so if it has unrestricted access to a terminal, the ability to rewrite files, and the physical control of a mouse and keyboard...
I know where you're going with this.
Isn't that a massive recipe for chaos? How are teams keeping this from just breaking everything? Because if a user provides a vague instruction or the agent misinterprets a command, it could easily initiate a destructive action.
It absolutely could.
Like an agent with that level of access could accidentally delete a production database or overwrite critical infrastructure configurations while attempting to solve a totally separate problem.
You're completely right. The potential for catastrophic failure is high, and that vulnerability is exactly why the industry had to rethink how humans instruct these models.
So they realized raw prompts were too dangerous.
Yes. If an entire engineering team is throwing unstructured, colloquial prompts at a highly autonomous agent, the system will inevitably break. To mitigate this, Anthropic shifted away from traditional prompting and introduced a rigorous governance framework known as skills.
Skills. Okay, so this represents a major shift from prompt engineering to what the sources call skill engineering.
Exactly.
Because a standard prompt is notoriously fragile. It's usually a one-off instruction, often kept in a single developer's head or saved in a personal notepad.
Right, it's totally informal.
Yeah, it might work perfectly for them, but it lacks the structure necessary for a broader team to replicate the result consistently.
A skill, by contrast, is a formalized, reproducible workflow. It is treated exactly like production code.
How does it actually live in the code base, though?
Technically, a skill is stored as a specific folder structure directly inside the project repository, centered around a configuration file called skill.md.
Oh, so it's a markdown file.
Yes, and this file acts as a hard-coded guardrail, teaching Claude exactly how to handle a highly specific, repeatable task within the bounds of the team's established safety protocols.
The report notes that Anthropic now maintains official, standardized skills to guide enterprise teams. For instance, they offer a front-end design skill that ensures all generated user interface components adhere to accessibility standards.
Which is huge for compliance.
Exactly. There's also the MCP Builder skill, which handles the Model Context Protocol, allowing the agent to safely connect to local servers or external databases without exposing sensitive credentials.
Right, that security layer is crucial.
They also have dedicated skills for testing and even a skill creator to help teams architect new workflows properly.
And, the architecture of how these skills are loaded into the agent's memory is just a master class in efficiency.
How so?
Well, think about it. If Claude loaded the full text of every single skill in a massive enterprise repository for every single query, the computational cost would be astronomical.
Right, it would just eat up tokens.
Exactly. And the model would quickly become overwhelmed by irrelevant instructions.
Yeah.
To solve this, they implemented a 3-layer loading model.
Okay, so a 3-layer model. Broke that down for us.
The first layer is just the metadata. When you give the agent a task, it doesn't read the deep instructions of every skill. It only scans the brief metadata descriptions attached to each skill.
Oh, that makes sense.
Yeah, it evaluates the current problem and asks, do I need this specific tool right now? This localized search saves a tremendous amount of compute.
And if it decides it does need it?
That triggers the second layer. If the agent determines a skill is necessary based on that metadata, it loads the full skill.md file into its active context window.
Got it.
This file contains the precise task types, the step-by-step operational instructions, the required formatting, and the expected outcomes.
What's the third layer then?
Finally, if the task requires deeper context, it triggers the third layer, loading supplementary resources like external testing scripts, company-specific templates, or dense reference documentation.
We can visualize this transition from prompts to skills using a culinary framework.
Oh, I like that. Let's hear it.
So a standard prompt is like a personal recipe a chef has memorized. They know exactly how much salt to add based on feeling, and the dish turns out perfectly for them.
But only for them.
Right, because if they hand the kitchen over to a new cook without writing anything down, the result will be totally inconsistent.
Yeah, it's a mess.
But a skill is the equivalent of a laminated step-by-step checklist bolted to the kitchen wall. It dictates the exact measurements in grams, the precise oven temperature, and the required resting time,
Ensuring that the entire restaurant staff can produce the exact same dish predictably.
Exactly, regardless of who is actually working the shift.
And that standardization is what elevates these tools to enterprise grade. A fascinating insight from the developer documentation reveals that when automated workflows fail in this system, it is rarely due to a breakdown in the agent's underlying logic.
Wait, really? Then why do they fail?
The failures almost always occur in the first layer, the metadata description.
Oh, wow.
Yeah. If the human author writes a vague or inaccurate description of what the skill does, Claude simply doesn't know when to trigger it. The agent ignores the tool entirely because the routing instructions were unclear.
That makes so much sense. And that dynamic forces teams to treat these AI workflows with the same rigor they apply to traditional software. You don't just write a skill and forget about it.
No, you have to maintain it.
Right. The reports detail how teams are integrating built-in evaluations to monitor performance. They run A/B tests on the metadata triggers to see which descriptions yield the highest activation rates, and they maintain the skill.md files through standard version control.
Exactly. And with this level of disciplined automation, the daily operational structure of a team fundamentally changes.
So what does that look like in practice?
Well, the sources outline a distinct three-stage adoption curve for organizations integrating these agentic environments. Stage 1 is characterized by localized individual speedups.
So just one person going faster.
Right. A single engineer uses ClaudeCode to map out a tangled legacy codebase, isolate persistent bugs, or generate a suite of unit tests. The impact is significant, but it remains isolated to that individual's machine.
And then stage 2.
Stage 2 occurs when the organization begins centralizing those workflows into shared skills. The team standardizes the way code reviews are conducted, builds uniform migration templates, and enforces a consistent format for internal documentation.
The automation moves from individual efficiency to team-wide consistency.
Exactly. Which leads to stage 3, the full realization of the technology. Sustainable, automated agents running as permanent infrastructure.
Like the night shift we talked about earlier.
Yes. The most effective combinations of ClaudeCode and custom skills are deployed as continuous background processes. And this stage catalyzes a dramatic shift in team roles and responsibilities.
This is where it hits the human element.
Big time. Senior engineers, who traditionally spend hours reviewing code syntax or debugging routine errors, are removed from the execution bottleneck.
And the data on this role transition is really compelling. When senior staff get their time back, they pivot from being executors to orchestrators.
They're managing the system, not writing the individual lines.
Right. Software architects and team leads spend less time writing individual functions and more time focusing on high-level governance. They define the safety guardrails, optimize the rules in the global configuration files, and strategically determine where it is safe to deploy autonomous agents next.
And we really have to examine the hard return on investment that justifies this structural overhaul.
Oh, the numbers are incredible.
They are. The aggregated enterprise reviews from 2026 show general productivity gains ranging from 26% to 55% across engineering departments.
55% is a massive jump.
It is. Furthermore, the reports emphasize that the most substantial gains are not realized by junior developers using AI as a crutch, but by highly experienced engineers who use the agents to offload the tedious, patterned work that consumes their day.
For example, IBM tracked a specific 45% productivity boost in deep refactoring tasks.
Right.
And a financial tech company called CRED reported a twofold acceleration in the delivery of new features, alongside a 10% increase in total test coverage.
Wow.
But the most striking example in the sources is a massive legacy modernization project. The organization needed to migrate an antiquated software system to a modern architecture. The initial projections estimated the project would take 36 months of manual engineering effort.
3 years.
3 years. But by leveraging agentic tools to handle the repetitive code translations and automated testing, they compressed the timeline to under 6 months.
That is just staggering. And while that scale of acceleration represents, an optimal scenario rather than a guaranteed baseline, the underlying trend is undeniable.
Mass refactoring is highly patterned, so it's an ideal candidate for agentic automation.
Exactly. But this leads to a critical expansion of the technology's scope. This level of automation is no longer confined to the engineering department.
It's the most exciting part, honestly.
I agree. The implementation of skills effectively packages complex programmatic logic into natural language triggers. And that unlocks these capabilities for non-technical employees.
The sources actually refer to this as the non-tech takeover.
I love that phrase.
Right. Like Accenture recently announced an initiative to train 30,000 specialists across various disciplines on how to utilize Claude.
30,000 people.
Yeah. We are seeing data analysts who have never written a line of Python using the agent to generate and execute complex scripts. They use natural language to describe a desired outcome, like converting thousands of raw CSV files, cleaning the formatting inconsistencies, and generating a synthesized report. And the agent writes the script, executes it against the local spreadsheets, and delivers the final product.
It's incredible. And the most illuminating case study in the 2026 report centers on a non-technical lawyer working internally at Anthropic.
Oh, the story is fascinating.
It really is. Legal professionals deal with immense volumes of unstructured data. This lawyer utilized the agentic environment, without writing any code, mind you, to architect self-service legal review instruments.
Just using natural language.
Yes, they build a workflow where the agent autonomously parses incoming legal requests, sorts through dense PDF contracts, organizes associated document files, and builds searchable knowledge bases from raw, unformatted scans.
And the results were wild. By automating the primary parsing and categorization of those documents, the lawyer dropped the turnaround time for legal reviews from a standard 2 to 3 days down to a predictable 24-hour cycle.
That's a game changer for legal operations.
Totally. The agent handles the administrative sorting, allowing the human to focus entirely on the nuanced legal analysis.
And the report highlights another early adopter corporation that achieved an 89% internal adoption rate across their entire staff, operating over 800 distinct internal AI agents for various departmental tasks.
800 agents running around the company.
Yeah. While that represents the bleeding edge of the current market, it clearly illustrates the trajectory of enterprise operations. However, the documentation includes a stark warning regarding the sustainability of these systems.
Which circles back to the necessity of governance, right?
Exactly. The report is clear that scaling agentic workflows requires strict operational hygiene. Organizations must implement clear deployment rules, assign designated human owners to audit critical skills, and maintain a rigorous review process for the agent's decision-making logs.
Because if an organization skips that governance layer in a rush to automate, the system deteriorates rapidly.
It absolutely does.
Without structured oversight, the repository turns into a chaotic graveyard of unsupported automation scripts and conflicting skills. The AI becomes paralyzed by contradictory instructions, and the human engineers spend more time debugging the automation than they would have spent doing the work manually in the first place.
Exactly. The technology provides immense leverage, but it demands an equal measure of discipline.
So zooming out, we are observing a profound evolution in how work is accomplished. ClaudeCode and the architecture of skills have transformed AI from an advisory chatbot into a dependable executor of digital logistics.
It's not just talking anymore, it's doing.
Right. The system is actively carrying the operational load for a wide spectrum of professionals. It assists senior developers executing complex architectural migrations, empowers data analysts to script mass data conversions, and enables legal teams to process thousands of pages of text overnight. It is no longer just providing the map, it is driving the vehicle.
Perfectly said.
So I want you to evaluate your own daily operations. Whether your role involves writing software, managing team logistics, or processing an endless stream of digital documentation, consider where the repetitive bottlenecks exist. Where are you acting as the manual bridge between two disparate systems?
Where you do the copy pasting.
Exactly. Where are you spending hours copying, formatting, and verifying information that follows a predictable pattern? The data from this deep dive suggests that a properly configured agentic loop could likely manage those pattern tasks for you, reclaiming hours of your time for actual high-level strategy.
It is a fundamental shift in the human-computer dynamic, moving from manual operation to strategic orchestration. But this transition leaves us with a critical lingering question as we conclude.
What is that?
If these agentic systems are now the entities actively writing the syntax, configuring the pipelines, migrating the databases, and executing the visual interfaces, what happens to the human muscle of foundational understanding?
Oh, wow. That is a deep question.
Right. In a future where professionals no longer have to build these complex systems from the ground up, do we eventually lose the capacity to comprehend how the underlying machinery actually works?
That is heavy. When the system becomes the expert at execution, the nature of human expertise must fundamentally change. We will leave you to ponder that implication. Keep questioning the tools you use and keep exploring.